This is about the VRRP networking and configuration. For the VRRP, I think most of the engineers already know, right? This is for the redundancy. Virtual root redundancy protocol. The full name. So what can it do? Here we give the three scenario. For the first one, is to use the VRP to make the redundant backup for the layer 3 switch and to improve the network reliability. So for the picture here, we enable the code switch as the gateway and enable DHCP service, and then assure the high availability of the gateway. So the code switch 2, this is in the VRP group. This is an standby device, and it's not forwarding any traffic by default. But when the master device is failure, and it will change to the new master and to start data forwarding. In this topology, any link breakup, it won't cause the business disconnection. And the gateway upgrade or maintenance, the business will still going on and without disconnect. The scenario 2 for the VRP is to make the redundant backup for the code switch. The link redundancy through spanning tree protocol to improve the network reliability. For this one, it's to combine the VRP and the MSTP protocol. Combine these two protocols together to make the redundant and to improve the network reliability. For next one, not only the VRP can combine with the MSTP, it can also combine with the MLAC. Here is to make the redundant backup of the code switch and equipment, and to improve the network reliability through the MLAC. Here is a notice for the VRP. Now, so Sundray switch, it can only support the maximum 2 devices in VRP group. And now, for the VRP protocol, we can support to join the VRP group with the other brands. For example, if for the VRP group, we can combine with H3C or Aruba, Ruckus, etc. So the next is about the VRP configuration. For the VRP, the first one is the first we need to configure the VRP master devices. For the FATP mode, we go to the high availability, the VRP policies, to add a new VRP policy. We give it a virtual IP address. For the VRP group, group ID of master and standby devices should be the same. Here we configure the group ID to 1, and for the interface configuration, we can choose VLAN if or VLAN if interface or layer 3 aggregation interface or normal layer 3 interface, just according to your requirements. And then after we input the virtual IP and select the interface, we can we need to enable the preemption function, and the DHCP service can be set according to the network requirements. If the DHCP service is enabled, the master devices need to select the service mode to use the local settings. For the master, if you enable the DHCP service, you need to use the local settings. And for the standby devices, we just need to choose to synchronize from the master. And for the switch parameter configuration here, is to configure the priority. The higher the priority number, the higher the priority. Here, the priority number of the master devices is set to 150. For the priority number configuration rules, we need to make sure the master device's priority bigger than the standby device's priority, and bigger than the failed master priority, and bigger than the failed standby device's priority. For next, we need to enable the tricked interface. Just now we have configured the priority as for the master devices. It's 150, right? And then we start to track the interface. If the interface the link has a system failure, and then we will change this link, change the priority of the master devices to the failed master priority. So action upon failure, we just decrease the priority to 100. So when the problem happens, the action upon failure, we change the master priority to 100, and then we need to keep that this priority will be lower than the master priority, because there is the packets sent between the master and the standby. It will always try to compare each priority. So when the problem happens, the master device's priority already lower than the standby devices. So the standby devices will change to the new master and start to forward the data. In the advanced option, we can configure the escrow group and synchronization group. You can decide whether to configure it according to your needs. For the escrow group, when the multiple VRRP backup group are added to the same group, the master devices with the smallest VRID in the backup group send VRRP packets instead. So this function is to reducing the number of VRP packets. Owning the master devices with the smallest VRID send the VRP packets. The other devices in the VRP group not sent. And for the synchronization group, the synchronization source is responsible for keeping the VRP alive. The member devices do not send keeping alive. The instance status is consistent with the status of synchronization source. So it can also help to reducing the number of VRP packets. For the standby devices, we go to the high availability. It's in the same configuration. It's in the same place, and to use the VRP policy. And the VRP group ID, we need to keep it the same with the master. Before we configure the group ID to 1, and here also the 1. And the virtual IP is also should be the same with the master. And then we enable the preemption. For the standby devices, we don't need to enable the service as a DCP. We need to choose the DHCP settings to sync from the peer. It means In the standby devices, we don't enable DHCP service, but the DHCP settings will be synchronized from the master devices. For the next, it's the priority. Just now, the priority of the master devices is 150, and the field master priority is 100. The priority of the standby devices is 120, and this number should be bigger than the field master priority. Also, we need to enable the tricked interface. So for this switch parameter configuration, we need more focus on the priority number. The master devices priority 150, standby devices priority 120. And when the master devices break down, it will reduce the priority to 100. And at this time, the standby devices priority will be bigger than the failed master priority. So it will change to the new master. For the phase switch VRRP configuration, we go to the switch management center, the high availability VRP policy, and to new the VRP policy. And then we add the VRP group, the group one, and choose the two switch. Set the master devices priority number to 200. Set the standby devices priority to 100, and choose the interface the VLAN if51. The virtual IP is this one, and enable preemption according to actual demands to enable DHCP service or not. Usually, we enable the DHCP service in the master. And for track the uplink, we usually can use the pin probe or BFD detection, or we just to detect the ports. In the advanced option, there is also the settings of group and synchronization group. These two features we usually use to reduce the VRP packets. The concept for the config the VRP group for the controller and for the switch, it's the same. If you understand one of them, you will easily to understand the other.